Now the main use of dot product is almost always to try to find the length of the projection of one vector onto another. Let's just talk about that basic picture before we actually try to start talking about general cases and formulas and whatnot. So if that's a vector u and that's a vector v, and we have light coming straight down onto v, where v is the screen, you can see this, the light would go like this, and we would want the length of the shadow. And that's actually what dot product actually attempts to find all the time. Given that we're always going to try to find the length of the shadow, what we're going to do is start in the nice easiest case. And what we like to do, the easiest case, is when the length of u is equal to the length of v is equal to 1. In that case, since dot product is invented to find the length of the shadow, what we'd like to do is just say, in that case, dot product is going to be defined to be the length of the shadow. Length of that shadow. Now, let's just draw a picture and find the length of that shadow. Then we'll go like this, we'll go like this. Here again, u's there, v's there. Here we go. Going to go like this. I want the length of that shadow. Well, let's use some trig. Let's say that there's the smallest angle between them. I want the smallest angle so I can draw a triangle. And what are we going to do? We're going to get that the cosine of that angle is equal to the length of the shadow that we want the dot product to be equal to, divided by the length of vector u. But we're assuming in this case that both u and v have length 1. And so what we're going to get is that the length of the shadow that we're interested in is actually equal to the cosine of the angle between them. So that's going to give us our first definition that if u and v are both unit vectors, then u dot v is going to be the length of the shadow, which actually turns out to be the cosine of the angle between them, which is great. The second step is, what happens if u and v aren't unit vectors? Well, if they're unit vectors, it gives us the right length. What would happen if they're not unit vectors? Well, okay, in general case, if I'm trying to look for a definition of u dot v, well, the rules have to apply. So this is what I'm going to do. If u is not a unit vector, I can turn it into a unit vector by dividing by its length. That's now a unit vector. If it was length 5 before, it's now actually length 1. I can turn v into a unit vector by dividing by its length. Like that. So that's a unit vector, that's a unit vector. By our first example, the dot product of two unit vectors should just be equal to the cosine of the angle between them. So that's going to tell us our definition for general dot product. U dot v is going to be the length of u times the length of v times the cosine of the angle between them. Like that. So that is our definition of dot product that we're going to be using all semester long. It's where all the good properties come from. It's not the formula, it's the definition. Notice, by the way, if u and v are both unit vectors, that's just one and that's just one, and we get our original definition back, which is great. Now, the third thing and last thing we want to do in this really brief introduction is to say, okay, wait, we're really interested in the length of the shadow of one vector onto another. That's the problem that dot product is supposed to help us solve, but I think we actually just lost that with this definition. So we want to go back and get our general formula for the length of the shadow of one vector onto another. So this is the third and last thing we're going to do in this video. I want the length, a general formula for the length of the shadow of one vector onto another. Let's see here. Well, the same formula applies just generally. I can write down that the cosine of theta equals L over the length of u. So the length we're looking for is equal to the length of u times cosine theta. The problem is cosine theta is hard to come by, and it's going to turn out the dot product is not hard to calculate. So what I want to do is rewrite my right-hand side, because that's the length of the shadow I want, so that it involves dot product. Well, remember the dot product is the length of u times the length of v times cosine theta, and so I'm just wishing that this actually had a length of v right here. Well, of course it doesn't. But what did I do to this term right here? I just multiplied it by the length of v. I can get around that, yes, by dividing by the length of v. Like that. And what that gives me is u dot v on top, like that, and then I'll usually put the length of v under this vector here. So that is our formula for the length of the shadow of one vector onto another. It's called the projection formula. It's just as useful as dot product, and an awful lot of what we do this semester will depend on that formula as well. So that's the brief introduction. What happens if they're unit vectors, what's happening if they're general vectors, and how do we get our projection formula back in terms of the dot product that we're trying to develop here.